All right, so we're out of time. Let's go ahead and get started. My name is Taylor Brown. I lead the program management team responsible for the container platforms at Microsoft. Big words. What does that actually mean? Well, I split my time. Part of my time is running the underlying infrastructure that runs containers in Azure. So if you run an Azure function, you run on top of the container platform that my team helps build and deliver. That's one half of my time. The other half of my time is working on Windows containers, helping customers bring those applications into the cloud, into a modern paradigm. And I'm joined with Wei Zhuan.
Yes, my name is Wei Zhuan Davis. I'm very pleased to be here. Thanks for coming. So I am the program manager for Windows Server Lift and Shift, and I work on Taylor's team. So I'm very glad to be here and talk to you about this session.
So something that I started doing a couple years ago, people seem to like it, so I keep doing it. The slides for this session are already available. You can grab them from this QR code. You can take a look at them. If this is not the content you need to be in, please go find a session that is. Go to this show floor, do something else. Don't waste time in a session if you don't need to be there. That said, hopefully this is the content you're looking for. We're going to go through a bunch of details on it. We've got some session links, and we're going to have some fun as we go through it. Other shameless plug, our team is hiring. If you want to be part of the container team, if you're a dev, if you're a PM, if you like to do data and insights, please send us an email, let us know who you are. We'd love to talk to you. We are looking for devs, PMs, data insight people, all sorts of stuff.
Okay, so let's get started. Now, why is there a lighthouse on my slides? So this is about container. Now, this is Rudberg Nude Lighthouse. It's based in the coast of North Sea in northern Denmark. Any Danish here? Okay, so correct my pronunciation after the session. It was built in 1899, so more than 100 years ago, and it's 23 feet high, weighs 720 tons, which is about 70 feet, and 1.5 million pounds, big and heavy. It is important. It has saved millions, counted lives, and dollars, right? However, it was built on sandy foundation. It's not solid. And also the coast erosion is happening really bad. Every year, by average, it erodes 1.5 meters, it's about 5 feet. So if nothing's done, it'll fall off the cliff in a couple years. And that's what's happening of that town. The town of that people are trying to save the lighthouse. I bet none of you have a lighthouse problem, right? Anyone? No. But I'm certain many of you have legacy application. Actually, someone talked to me at the booth. They have application like timestamp 1988. Like, wow. So you have the old application built on old foundation, which is not safe, not secure, expensive, hard to manage, all the pain points. And by the way, you know, Windows Server 2008 and R2's end of life support coming January. That's less than 3 months away, right? So what do? This is what it's about. This is what Windows Server Container Lift and Shift is about. We're going to get to that today, tell you how you can move your application from an old foundation to a new one, and you have a forward-looking path. Back to you, Taylor.
So some of you probably saw this slide when I talked about it in our Windows Server What's New and Next section earlier, but shouldn't be a surprise to many of us in the room, but sometimes it comes as a surprise. 72% of on-premise workloads are on Windows Server. 72%. Now, when we look at some Stack Overflow data, this is a survey that's been run for 6 years, so it's got a nice kind of set of data on it. It's like any survey that's not perfect, but it's a great snapshot. We see that just C# accounts for about 1/3 of all application development. Right? People are writing applications that are running on Windows Server. They have been, they continue to be. When we dig into this data a little bit more, so this is 2019, just a snapshot of 2019, ASP.NET. These are ASP.NET apps that are running on IIS, 25%. When we look at the middle tier and back-end services, some of the UI components, .NET, not just .NET Core, just .NET itself, it's like a third, right? These are people who are writing applications on a Windows server. Why does this matter? Well, we think it matters when we start to think about how we modernize those applications. How do we make sure that those applications can run in a modern way? Wouldn't it be great if you had a single place that you could go to see all the applications in your environment? The Linux ones, the Windows ones, what version they're running, are they healthy, are they not healthy, are they patched, are they not patched? Wouldn't that be awesome? Yeah? That's some of the promise that we get through containerization. And we're going to talk a little bit about that as we go through the session, how we leverage orchestration, how we leverage containerization to do that. Containers also deliver us faster innovation. They deliver us a faster time to market. And something we found from our own teams doing development, the dev teams that can deliver value to their customers, that can fix things and deliver new features to their customers fast, are happier. We have higher retention rate, we have higher job satisfaction, and we have higher productivity out of them. The faster they can go from keyboard to happy customer, or keyboard to less happy customer, but I can redo it and make them happier, the happier they are, the more productive they feel. If they have to wait 6 months or a year for an application to go from code to production, it's kind of tough, right? It's hard to get excited about, hey, I'm going to go to work today and I'm going to do this, and a year from now, maybe it'll get into a customer's hands. If they go in and say, like, yeah, I fixed that bug at 10 o'clock in the morning, before lunch it's already live, that's pretty awesome, right? And then we have the ability for our applications to run anywhere. We all have a global world now. Maybe you need your applications to run on-prem. You've got a regulatory requirement. They have to run in your private cloud. Great, we can do that. Tomorrow you sign a new contract with, hopefully, Azure, but maybe it's another cloud, and you can move that application to the cloud, or you want to move that application to the cloud. Great, we can do that as well. And containers make it easier for us to do it. Is it impossible to do without containers? Of course not, but they make it easier. Now, some of our data helps back that customers are getting excited about this. One of the trends that we've tracked since we started with Windows containers was the monthly pull rate of our base images. It's just one metric, but it's a metric that helps us kind of see, like, how are people using this? In October, we had 5 million people download a Windows container base image. Many of them are running in enterprises. They pull at one time. They run 10,000 containers behind the scenes. Some of them are developers. They're pulling 10 or 15 of them. But it gives us a good sense for how people are using it and how often they're using it. Right? We see server core still being the dominant container image. Nano server picks up a little bit. We saw a huge spike in September. We see these spikes every now and then. This one was pretty specifically massive. Great to see. Right? So we know that people are using Windows containers. Another metric that we've started looking at now that we've got AKS in preview, how many people are using AKS with Windows, right? And we see that the trend is up and to the right. That's what you want to see if you're a product manager. You want to see numbers that go up and to the right. Unless it's error rates or dissatisfaction, then we don't want to talk about this. These are good ones, though. Core usage is up. Unique customers are up. We're seeing people adopt and use Windows containers and AKS to drive adoption. So that was some qualitative data. How about some, that was some quantitative data. How about some qualitative? 3Shape, CAD/CAM software company. We believe that AKS Windows container support could be a game changer for our adoption, for the adoption of our use of Windows containers. Some of our code only supports Windows. Having a container platform which is reliable and easily manageable is of great importance to us. It's just a piece of data that kind of supports that previous slide on the adoption that people are having. Right? Now, we've been working on the platform component of it since 2016. And we've really tried to have continuous innovation. We've got a semi-annual channel. We can push out fixes faster than we've ever been able to before. So when we started with 2016, my clicker will click, there we go. Our base image was 5 gig. That's a huge base image. A lot smaller than a VM, but quite a bit bigger than most Linux-based containers. Right? It took about 7 minutes to pull. We had some basic support for Active Directory. Apparently, that's something people use with Windows containers and Windows applications. I don't know. We didn't have MSMQ support. That was apparently something people use when they're writing applications. We had no log integration. We didn't have any SQL Server support. We had containers, but they were fairly basic. When we got to 2019, we've gotten that image size down to 1.5 gigs. It's over 3 times smaller. We've got room to go, don't get me wrong, but it's a huge amount of progress that we've been able to make in it. That reduced our download times to 2 minutes. We've got much better group managed service account integration. We still have room to go, but a lot better. We've got MSMQ support in some basic scenarios. We got a POC of a logging tool, and we've got a public preview of SQL coming soon. What are we working on now? Well, we're going to get that image size even smaller. We're trying to get it under a gig. That's a goal that we've set. That's a goal that Wei Zhuan set when she first started on my team. I want to get that image down to a gig. We've got some work underway to make the performance of pulling images much faster. It's going to be pretty awesome. We've got GMSA work to integrate with Kubernetes. That's already in beta. We're trying to get that advanced into stable. We want to finish up our MSMQ and our DTC work, make that work for everyone. And we've got some cool things we're going to talk about with logging in a few minutes here. We've got a couple sessions. If you want to learn a little more about this, highly recommend them. If you can't catch them in person, of course, all these are recorded. But with that, I'm going to flip over to Wei Zhuan, and she's going to give us a demo of what we're going to see today.
Thank you, Taylor. So, demo, I need to switch to my machine here. Okay, so let me first introduce you to iBuySpy. That's the application I'm going to use throughout this demo. iBuySpy is a web-based catalog sales site. Catalog sounds very old. It is. It is based on ASP.NET 2.0. This is about 20 years old, right? Not as old as Lighthouse, but it's pretty old. And you can, today actually works. You can go there, you can click, make some orders here. For example, I like some earrings. I can always use a new one. So you can, see, you can make orders. So it's old ASP.NET application. The UI is based on ASP.NET web pages, and the data here is actually through a SQL database via store procedure. So all the familiar concepts. Now, next, I'm going to show you, I have this application already containerized and up running on Azure Kubernetes Services. So I'm going to switch to Azure portal here. I already have a Azure Kubernetes service. I have a cluster already created on the Azure Kubernetes Services. Let's take a look at what I have here in the Overview tab. You can see I have a resource group. I use Azure East US location. I'm actually zoomed a little bit here. You can see here. I have 2 node pools here. So I'm going to double click on, see what's under the node pool. So you will see that there are 2, no surprise. One's a Linux, which is the master of the Kubernetes, this cluster. And it has 2 nodes under. And the other one's Windows node. And that's where my applications are deployed. To show you my application, let me quickly switch to the Insights view here. Take a few minutes to load. More than a few minutes, less than a few minutes. You can quickly see how the cluster is running here, with CPU utilization, memory, etc. What I'm going to show you is here in this deployment tab here. You will see all the containers are deployed here. And this one, iBuySpy-LM, is the application I already containerized. I'll explain why I have the LM later, but this is the container I have up and running. Now to show you it's actually real, like up and running, I'm going to go to this side with this IP address. It's very close to what I showed you earlier, the iBuySpy site with some minor UI change. And I can order information. Since we're all traveling, why don't we go to the travel section to see if anything interesting. Yeah, escape sounds cool. Let's add to that. And also, I was hungry. I ordered some bar here, so I can make order here. Now, all those today, this is already lift and shifted running on Azure. But how do I know that is true? I'll show you here. I'm going to switch to a PowerShell window. With the ctl command, I can show all the pods and nodes services that's already deployed. And here, this line shows the container that I deployed earlier at this IP address. And that exactly is what I show you here.
All right. So we're going to see in a few slides in a few minutes how we actually got through all of that. Like, what did it take to move that application? We're going to walk through all those steps. But that's just a sense of kind of what we're going to do in the rest of this session. So let's talk a little bit about Kubernetes and Azure, right? So we talked about Windows containers. We see all those. Like, why Kubernetes? Why Azure? Why would we use these two together? Well, let's start with Kubernetes. Kubernetes has won the container orchestration battle. It is the container orchestrator that everyone has broadly aligned on. And when we talk to customers who are using it through the Cloud Native Computing Foundation, which is what owns and kind of operates the Kubernetes community, 42% of them said, yeah, our big reason is portability. We can move not only the application, not only the container, but the entire configuration from one cloud to another cloud, because all of them have a Kubernetes service. I can run it on VMware, I can run it on OpenShift, I can use it in Azure, I can use it in AWS, Google, wherever I need to run it, and it's broadly the same. There may be a few minor details, but most of it is the same. It's really like a true realization of cloud portability, right? 45% said scalability. It's just really easy to scale things up and down. We're coming into the holiday season. A lot of us work or have worked with e-retail. Yeah, you're going to scale up, and then right before Christmas, you got to scale right back down, right? It makes it easy to scale up and down. And then agility. That was the last big reason. 50% said agility. It makes it easier for them to be agile. Developers are getting trained in it. Operations teams are getting trained in it. It's common. They understand how to use it. So why Azure? Well, we've made it really easy, and we'll see in a minute here, to get started with Kubernetes. A couple clicks, a couple commands, you've got a Kubernetes cluster up and running. Really easy. That allows you to accelerate your deployment and your development times. It allows you to automate even the infrastructure creation tasks, right? So you can automate, I'm going to recreate my Kubernetes cluster every month. Why would you want to do that? Well, things happen. Maybe someone screws something up. If you're recreating it regularly, no big deal. You've got it all scripted. It's easy to do, right? It's built on the Azure Foundation, so of course it's enterprise grade. And then we're doing the management of the Kubernetes instances for you. And so if we look at kind of a delta between what does it look like to run your own Kubernetes, right? It's an open source project. I can just grab the bits, do it myself, right? Well, you're still going to do the containerization with AKS or with Kubernetes. We can only help you a little bit with that. That's something that it's kind of personal, right? It's your application. We can help you with the CI/CD pipeline. We can give you some great tools and integrations, but ultimately, it's got to integrate with what you have. Maybe you're using Jenkins. Maybe you're using GitHub. That'd be great. Maybe you're using some other source management. Maybe you just have a bunch of VMs that are turned off under a desk that are running old versions of Visual Studio 2005 that you boot up every now and then when you need to make a small tweak or fix or build. I hear about it all the time. It doesn't surprise me. I know what it's like to try to upgrade a VS Code project. Yeah, some of the time it works, some of the time it doesn't. But then the rest of it we can take care of for you. We'll manage the node pools. We'll manage the versioning. We'll give you the tools to upgrade. We'll give you the command line. You just run one command, and we'll upgrade all of the nodes for you. Right? We'll take care of all of those pieces. And you don't pay us for that part of it. You just pay for the nodes that you're using. We take care of all the management. That's just part of the deal. So what does this look like when we talk about Windows containers? Well, we saw the two node pools a minute ago. So what we actually do is we have a set of Linux nodes. Those Linux nodes run the Kubernetes pieces. We could port those to Windows, but really they just run better on Linux today, and it already works. So we just set up our Linux node pools. We run a couple VMs that are running those. Job done. And then we add in the Windows nodes. So now we have a pool of Windows capacity. We have a pool of Linux capacity. The Windows applications land on the Windows nodes. The Linux applications land on the Linux nodes. Now what's really cool is we can actually span those. So I can have an application that is comprised of Linux containers and Windows containers. So a good example of this is maybe I've got some ASP.NET app, typical kind of 3-tier application, but I really want to put a new Angular or Node or a new front end on it. I want to make it look pretty and modern. I can change that app a little bit, make a web service out of it, put some REST query around the actual core business logic, unchanged, and then throw a new set of containers up that are Linux-based, running those applications, all within the same Kubernetes instance. Kubernetes doesn't care. You'll see it as one app. You'll see the pods being comprised of both Linux and Windows. You can update it just like one app. It's really cool. And it allows us to breathe some new life into an application that might be getting a little stale. Now again, we got some customers who've been talking about this. So Duck Creek Technologies, they do really fun stuff, insurance. They provide insurance services to insurance companies. Like, if you're an insurance company, you want to sell me some life insurance, they've got a platform for you. And they've been using AKS. They did a bake-off, looked at AKS, looked at a few different Azure services, chose AKS. They've been really happy with it for their Linux apps. Now, they're getting ready to bring their Windows apps in. They want to do it as soon as possible. Why? One pane of glass, one way to manage everything. Super easy for them. Now their devs don't have to choose Linux or Windows. They can just do what they want to do, and both of them work. So we're going to kick back over to a demo here. We're going to go through the steps. We're going to containerize an app locally on a laptop. Right? We're going to move it from just code from GitHub into a container. Then we're going to push that container image into an Azure Container Registry. Then we're going to deploy an instance of the Azure Kubernetes Service, push that container into it, and then we're going to talk about how we can do some monitoring with Azure Monitor. Right? So here we go. This is the big payoff. This is going to go through soup to nuts. And back to Wei Zhuan.
Yes. Okay. So we're going to do the first step. Containerize the local application locally. Here, I'm going to show you the source code, just a quick glance. This is the iBuySpy source code. You can, if you're interested, you can definitely open in the Visual Studio and see the details. The secret sauce, I shouldn't say secret, it's not secret. The key element to containerize application is called Docker file, which essentially is a script to help you to define what it takes to build a container, meaning from your application files, the respective operating system files, framework, or other configuration, et cetera, and as a script to guide you through the building process. So here, let me show you the Docker file I have for iBuySpy. Now this Docker file has actually two stages. Let me quickly explain what they are. One is a builder stage, the other is runtime stage. The builder stage basically build your application here from this folder. The benefit of having the builder stage is you can have the latest SDK and also OS together, so you have the best performant operating system, latest, and matching versions between operating system, application, and the framework, right? And also, later on, we'll touch on the Azure Container Registry. With the builder stage, Azure Container Registry will be able to see what versions you have and automatically detect if there's update on Patch Tuesday, for example, so you can have in your automation CI/CD pipeline. So then the second stage is runtime. Mainly, you already built application. Now I need to prep what runtime I need to have. Runtime bits. So you have the ASP.NET here. That includes IIS, includes a few configurations that you're probably familiar with, et cetera, here. So this is a Docker file. If you'd like to know more about how the two-stage Docker file is built, we recommend you read a blog from our .NET team. In fact, the slide speaker note has a link. So I highly recommend as a best practice. You don't always have to do that, but it's recommended. And also, I recommend you use Server 2019. As Taylor mentioned earlier, it has the best performance, smaller size, and also you can have the better benefit performance .NET with that OS image. So that's a Docker file. That's where you can start from. Now, with that, we can go to a PowerShell window to do the build here. So to do that, we just run the Docker build command. And the -f, the parameter, shows you what the Docker file, where it is. In this case, it's under this folder. Or if you're under the same folder of the current folder, you can just leave it as a dot. And -T shows what the target image you want to build. So I give a name, iBuySpy Live. You can give any name you like, and you can add tags as well. And last dot tells you, okay, I'm building in current folder. So the build may take a few minutes. I'm going to kick it off, so give you guys a sense how it runs. So as I said, Dockerfile basically script how the build works. You will see here in the screen in a few seconds, it shows different stages. Stage 1 of 10, 1 of 18, 2 of 18, etc. That give you assurance, okay, this is actually happening. So Docker, the daemon background is actually busy working here. Okay, apparently this takes longer than. Okay, that's coming. I'll show you the contact document is running. We'll just let it run here. You see, this is this is what we saw earlier in the Docker file. The stage 1, you get OS image. 2, you open the PowerShell as a shell, and then you work in the current directory, etc. So it'll take a few minutes. So I'm going to leave it on background. I'm going to open another PowerShell window so we can continue work on that. Now, on my local machine, I already have a bunch of images, my local image repository here. You can see I have image as old as last Ignite. I was presenting here as well, or a build. So a lot of them, and also I have already pre-built image, and it's up and running. I do that by running the docker ps-a, the command. You can see it's up and running here. Now to see that, I'm going to switch to browser to show you how it works. Remember, just pay attention here. There's a port mapping from the container inside port 80 mapped to the localhost 8080. So I can run through the local host to access the container. So here I have it up and running here. Now let's give it a try. So here, let's say I wanted some from the deception category. Wallet, I can use a new wallet. It's expensive, but okay. So it's working. Anything else we like? Maybe bacon, sounds good. Okay. So it's working. It's working as a local container, and you can access through the local host, the port 8080, right? Okay. Now let's see if quickly show you if it's still going. Okay, we're going to leave it at back burner. So by now I already show you how you containerize application with Dockerfile and build it, and now you can actually run up and running, and you can see the results in the local browser, just like you run the application in the VM or physical machine. I'm going to move on to the second step of the demo, show you how I use Azure Container Registry to manage my container. Now, why do I need Azure Container Registry, you may wonder? Because we are going to deploy the image to the public cloud, right? And oftentimes, enterprise, you need to work with team. So there should be a common, safe, secure space. And it needs to be a registry somewhere people can share. It could be Docker Hub, right? Some of you are familiar with, or it could be other third-party cloud provider. In my case, I choose Azure Container Registry. It can build, store, secure, replicate, and actually run different tasks as you like. It's more than container image. It can also manage other artifacts such as Helm charts, for example. So here, we're going to switch here. In fact, I will show you now to push your local container image to the Azure Container Registry. You will need to create a container registry on Azure. I'll show you here. In fact, I'll go back to this portal side, my home page. I already created Ignite 2019 container registry here. So let it load. It gives you overview here. And similarly, it's under the same resource group I have been using here. And I also have a repository here that visually shows what container image I have there. If you are more comfortable fan of PowerShell, you can definitely use PowerShell to populate image. For example, let's say I want to try, I have an image local I by SPY already, right? So I want to push to ACR. First of all, you want to tag it right. So we'll be tagging the local image. It'll be a long command. Let me type it here. I by SPY. And you want to give the container registry name. In this case, Ignite 2019 container registry. And URL here. And I by SPY. So you tag it, and that prepped your next step. You can push that image to the cloud. And with that, the long path, it knows where to push. So I'm just run it. This actually, nothing should happen because I already have one tag this way, right? Let's pretend this is already happening, already did happen. Now I want to push this image to my the registry. I'll just copy this and on Docker push here. Oop, that's not what I want.
And one of the nice things is that these images are all versioned. So everything you push until you explicitly delete it, you keep. So if you push a new version and you get up to the cloud and it's like, ooh, that didn't work, you can easily roll back to the previous version.
Right.
Super easy. And you can do all the auditing. You can see what people have been pushing, what versions. All of that information is within the Azure registry.
Yeah, thank you, Taylor. So in fact, this one already have on the Azure Container Registry. That's why it tells me, okay, the layer is already there. A layer is a concept container, basically, from OS and framework updates. So some of the layer already there, or most of it there. So you can see already there. Now, by then, you already have the container image on Azure Container Registry, so you can next deploy. So now we're going to move on to the third step. How do I have a Windows node running on Azure Kubernetes cluster and launch the application? I'm going to show you next here. So I already have here I showed earlier Ignite the cluster created here. And we're going to go a little bit deeper here just to refresh our memory. There's two node pool here. One's a Linux and one Windows. To see what's under here, you can come here. And I have it deployed here. Now, how do we get there? There is a well-written tutorial actually online. It's in the link of our later session, or you can get the link here. Basically walk you step by step how you add a Windows Server container on Azure Kubernetes cluster with Azure CLI. And what I'm going to show you actually all PowerShell. So that also proves you don't need to have to use Azure CLI if you're not familiar. You can stay with PowerShell. What you need is you need to install Azure CLI on your machine. And I'm going to quickly walk you through this tutorial. Seems it's lengthy, it's long, but it's worthwhile, and we'll pick a few things to quickly explain. So here you install PowerShell, Azure CLI, and make sure you register the extension, add extension update, because right now Windows Container AKS is still preview, so there's some extra steps here. And you register the namespace, and then you can see the list here, feature, for example. And we already created a resource group earlier here, so you don't need to do this. The key thing I want to call out are two things. One is this step, create AKS cluster. Here in Azure command line, you see you need to define the password, and you run Azure AKS create. You need to specify resource group, name, node, etc. Specify the network, etc. So it's very important. As a starter point, just follow that, but you can easily do that in PowerShell. It takes about 10 minutes up and running. You can feel free to grab coffee to do that. And once that's going, the next step is add a Windows Server node. And you will be running the Azure AKS node pool add. So the first step gives you the master node, which is Linux. Now to add on that, you would do a Windows, and you make sure you have call out OS type, and you can define how many nodes what you want to have, and have a respective Kubernetes version as well. Once that's happened, you can connect. So basically, to show you here, I have my Windows, the iSpy Live finished building, so it's successful. Now I already have the command stage, so I'm going to show you here. I won't run it because it takes time, but I do want to show you here if I can find it. This is the PowerShell format of the command. How do you create a Kubernetes cluster through PowerShell here? And once you do that, then you can add a node pool here. So it's doable, and I'm not going to run here. One thing I do want to call out, in fact, that's not necessarily in the tutorial, is remember we had Azure Container Registry created. It's not a point in the doc, but it's important is you want update the cluster to be able to connect with the container registry, so they can access, the cluster can access your container registry, which is run by, I have a cheat sheet here. You're going to see all my cheat sheet here. Okay, so it will be this command. And we definitely will share, you will.
We're going to update the docs.
Yes.
We'll say that.
That's right. We'll continue improvement.
When we were talking about this and both of us tripped over the same thing, it's like, maybe we should put that in the docs.
Right. So this is very important. It's not in deck, but in the doc, but we'll make sure you know that, and we'll update the doc. You want to make sure your resource group, the cluster, can attach to the registry, the container registry attached to your cluster here. Okay, once that's done, now we can deploy application. Now to do that, if we go back to the tutorial, you will find it shows you want to use a YAML file, a sample YAML file. It's pretty standard. It's pretty safe to reuse. I had, give you a name, how do you want to call it? Sample, or in my case, I call iBySpy-lim, and I'll explain what LM means for later. And the key thing is, you replace image. In my case, I'll be using the one I have on my container registry. In fact, I'll show you here, VS Code, I already have it. We have one opened earlier. So this is my version. I have a name. I have 2 replicas. I have my container registry and with the path to the container image here. And rest pretty much the same as that. It's pretty safe to use it. Okay, so now we have the containers there. We have Azure Container Registry up there. We have a cluster created, and Windows node is up and running. The key step is just deploy it. And to do that, with that, we can just run the command kubectl. I should mention that kubectl today is not come natively in with PowerShell yet, I believe, but you can easily download it. So you'll be running kubectl apply-f and point out your YAML file. In this case, mine is something wrong with my keyboard. Trying to find it. Okay, this is my YAML file, so I can apply and I can run it. I already have it up running, but you will see nothing has changed. Okay, it's configured and not changed because I already deployed that container. Now once again to see it's up running in Azure portal. I'm going to show you here a node here running. I have multiple containers.
That's one of the cool things, is just by setting the replica and a load balancer, she took an application that wouldn't have normally had redundancy and added redundancy to it. And if we needed to scale up, all we have to do is change that YAML file. We go from 2 to 4 and run the same command, kubectl apply-f YAML. We've got 4.
Right. Yeah.
And then with AKS, we've got horizontal node scaling. What that means, fancy term, we will scale up the number of VMs backing that node pool. You can set this up to automatically trigger so that as the resources grow, it will scale up the number of nodes for you automatically in the background.
Yes. So we're going to actually show you a little bit later the scaling if I have time. But I have it up and running. Now for fun, I can show you things that we deploy. We can run the kubectl to get what's happening now. Get all. It will show you all the services and deployment. And let's try, see if we can see, describe a pod, describe this pod. This gives you a little in-depth look how the pod is running here. And pod is sort of like container of the container, right? Multiple containers can be run on pod. Okay, so now we have it up and running and deployed on Azure Service. And just as the beginning I showed you, it's already a run. So basically we finished the step from a application containerized, populate to Azure Container, and now it's up running Azure Kubernetes.
Cool. Everybody kind of follow along with that? That makes sense? Yeah? Pretty straightforward. The hardest part people always kind of trip on is, how do I get that Docker file going? And really it's sit down with that Word doc that has your deployment steps, right? Everybody's got one of those. It's like, all right, here's how we deploy blah, blah, blah app. And it's step 1, copy this MSI over. Step 2, click this thing, click that thing. The trick is just to find the command line for it, right? If it's IIS, there's like PowerShell command line. We've got native CLI command line. You find the command line for it. You add that in as a run step. It's just like writing a batch file. People written batch files before? A few of us? Yeah? It's kind of my start of my career. So that's how we get started with it. Now, one of the things we said we were going to talk about, but we didn't show, was how we monitor this with Azure Monitor. Well, this used to be kind of a pain. We're really excited that just yesterday we published the blog and the repo to make this easier. Before I get to that, I'm going to show you kind of what the problem was, though. So in Linux, applications generally just log to standard out. You run the command, it logs the standard out. Maybe you're running it as a background service, it still logs the standard out. So that was really easy for the ecosystem to pick up. They just said, all right, cool. Whatever process is running in the container, it's going to log to standard out. We'll just take that output and we'll dump it into some logging tool, whatever logging tool you want. Well, Windows is a little different. Right? We have event logs. We have multiple different types of event logs. We have event logs on event logs on event logs. We have different channels of event logs. We have ETL, ETW, perfmon. We have all these different ways that we monitor our application, none of which natively go to standard out. None of them log to the output. So we had a couple choices. We could either build a brand new ecosystem to log and monitor Windows containers, or we could just integrate with the existing ecosystem. Well, we chose the latter. We basically just wrote a tool that just reads ETL, ETW, perfmon, all those things, and spits it out to standard out. Why? Well, now Windows containers behave just like Linux containers. Pretty straightforward. This is the first of many tools. How many people have ever used the Power Toys, Windows Power Toys? Yeah? Well, that's what we're going to do. We're going to build container Power Toys. We've made an open repo. We've published this first tool there. We're going to migrate some of our other tools over to that repo. And what we really need from you is go onto the repo, give us feedback about what other tools you need. A couple of the ones that we've come to mind is credential management, so better GMSA support, certificate integration. We want to extend Service Monitor. Those are a couple that we've been thinking about. But your feedback is going to ultimately derive what we put here. We have devs sitting there waiting to start writing code to make these tools better. Now, the cool thing is they're open source. We don't have to wait for a new version of Windows. We're going to write these tools actively. As they get to a level of quality and we get some validation for you, we're going to put them into the base image by default. They're just going to be there. So they're just going to be part of the images. You got a great idea for a tool? Put it in there. You want to write some code? It's a cool place to get started. So we're going to do a quick demo of this.
Very quick.
These 50-minute sessions are a little tricky.
Yes. Okay, so we're going to jump back to the Docker file. And Taylor mentioned the log tool here. Basically, what's needed, you basically copy the executable and JSON file, the configuration file, to your container image, and you run the shell, the executable, and you still use the entry point for the IS monitoring. And here is the configuration file. Now, to show and already built the image -lm, meaning log monitor, right? Already built that way. So to show you that's in action, I have show you early on. I have the iBySpy LM monitor running, and with view live data, I already show some log here. If I want to click more, order more, there will be more data showing up, service, etc. It'll be coming. So basically, it will go show onto this log file, and you can see the different IIS information, etc. So you can manage your application online right here. So
Yeah.
be quick here.
And because it's all just built into, you want to flip back over.
Oh.
Because it's all just built into the existing kind of ecosystem.
Num 5.
If you're not using Azure, if you're going to use some other Kubernetes tools or logging, all of that's going to integrate as well because it's all just part of the same ecosystem now. So quickly, one of the big questions we often get is, all right, what are some problems? What are some things that I'm going to need to do from going from POC to production? Well, that's a session all in and of it to itself, but I didn't want to leave you without that information. So in the speaker notes, for each one of these topics, there's a set of links to our documentation on what we talk to customers about. Now, this isn't going to be an inclusive list. Your environment's going to have speciality. If you've got questions, we will be at the booth all week. We put our email address in the deck. We're on Twitter. Please don't hesitate to reach out. We'll do our best to help you, point you at resources that are relevant to the application you're using. Now, real quick, just one more quote from Sitecore, another one of our customers. They are able to confirm that AKS can support their needs for performance, scalability, and reliability. AKS would likely become the technology on which our vNext initiatives are built. This is another customer who's using Windows containers in preview on AKS and excited about getting started. So I'm going to...
Oh, I just want to close because we prepared this video to show you. So this lighthouse, it took the folks in that town 6 hours to move, and it cost them 5 million kroner, which is about $750,000. So it's expensive and costly and painful. And your journey at lift and shift doesn't have to be away. And you don't need to wait. You should get on right away. We have a lot of links. So start today. Come to a booth, write to us, call us, and we will help you put on your more sustainable path forward. Thank you. Enjoy the video. Next.